Hello, welcome to the College Algebra Exam 1 review, Part 3. So in Part 3, we're going to be looking at question number 28. So on question number 28, we need to solve the equations in quadratic form by using appropriate substitutions. So in this case, I'm going to look at Part A, and I see that there's this expression in two places. So that kind of gives me a little bit of an indicator of I need to maybe sub in those cases. So in this case, I'm going to use the term u as their substitution. So u equals this expression 2 plus 3 over x. And so now that I have that, I'm going to plug in this u anytime I see this expression. So I'm going to do u squared minus u equals 12. And I'm going to move this over to the ax squared plus bx plus c form so that we can have a little bit more of what this should look like, what we usually see. So now I should have it like this. And so now that I have that, we're going to FOIL this back in and do u, put two u's there so that we have that u squared. So we need to find something that multiplies to 12 and adds to multiplies to negative 12 and adds to negative 1. So we know common factors of 12 are 6 and 2, 4 and 3. So you see how 4 and 3, I can see how I could get a negative because I could have a 4 that's negative and a plus 3, which gives me the negative here when they add together the negative 1, and then I times it and I get negative 12. And so now I can have two solutions for u. So u can equal 4 and u can equal negative 3. And so now that I see that, I have the answer for u, but I don't have it for x. So I need to set these u's in this original equation and solve for x. So 4 equals 2 plus 3 over x. And then I also have negative 3 equals 2 plus 3 over x. I'm going to move this 2 constant over. So I'm going to minus 2. And then I'm going to have 2 here equal to 3 over x. And then I'm also going to have this here and have negative 5 equals 3 over x. And so the thing we can do, so if I have a equals 1 over b, this is also the same thing as me timesing by b, and then I have BA equals 1, and then I'm dividing by a. So the thing you can think about it as is that I'm just going to put whatever is on top of here onto the other one. So I'm going to do 3 over 2 equals x. And so then on this other side, I'm going to do the same thing because that's on the top. So I'm going to get x equals negative 3 over 5. So that negative is technically with that negative 5. I just put the negative on top to make it look a little bit more formal. So now we have two solutions for x. We have x equals 3 over 2, and we have x equals negative 3 over 5. Okay, let's move on to Part B. So for Part B, it looks a little different. It's something that you just have to look at for a second. So the one thing I see is this 1/5, how I had in these expressions, I had the same thing in here. I'm going to look at this in the same way here. However, I know I want this term to be something to the squared. So I see that if I take exponent rules, I know that if I had t to the 1/3 times 4, I would get t to the 4/3. So I'm going to take out the same thing here, where I'm going to make this a squared, and I'm going to make it to the 1/5. Because then I can see here, 2t, and I can do t to the 1/5, and this will just have a power of 1, and then I have the 24 here. So then my substitution in this case is, let's say u equals t to the 1/5, and I can put in u squared minus 2u, and then we can put it to the first power, but the first power is just whatever the expression is itself, minus 24. And then I'm going to move that 24 over, and then I'm going to re-FOIL that back in. So I'll have u, and then I have to think of two things. So 24 can have 12 and 2. It can also have 6 and 4. It can also have 8 and 3. And I think the ones closest with a difference of 2 are these ones. So I'm going to use 6 and 4. I'm going to give the negative to the 6 because I know I need this to be negative here when we are looking at this negative 2. And then I want this to stay negative I need the 24 to stay negative as well, so I'm going to do a +4 so I can get that negative once I multiply them. So then I found out that u equals 6, and I also found out that u equals -4. And so now, like the previous one when we had part A, I want you to set what you had as your u. So our u was up here is t to the 5th, t to the 1/5. And so then I'll have t to the 1/5 equals 6. And then I'll also have t to the 1/5 equals -4. So in order to get this 1/5, I need to times this by 5, not times by 5, but put it to the power of 5, so that if I do 1/5 times 5, I just get to a power of 1. And so then I have t equals 6 to the 5th, and then I also have t equals to the 5th here. And so also remember, when you're doing anything to an odd power, this negative inside will always come back out. So if I have -4 squared, or if I have -4 to the 3rd, I know no matter what here with the 3rd, I'll get a negative out, and then I will get a positive with this. So with that being said, I'll have 4 to the 5th, I'll have a negative of the 4 to the 5th. And so I'll have 7,776 as your t, and then the other t will be a negative value, -1024 or 1,024. So now I've solved for my equation for t. Okay, let's move on to question number 29. It says solve the literal equation for the indicated variable. So v equals 4/3 pi r cubed, and then we're going to be solving for r. So for r, I want to get everything away from r cubed first. So the first thing I'm going to do is I'm going to you can times by the reciprocal, or more like the flip value. Reciprocal indicates that you have to flip the sign as well, but in this case, we're just flipping the fraction. So we're going to times by that, or you can divide by 4/3, which is doing the same things as timing by 3/4. So we're going to times by 3/4. We're going to have that equal to pi r cubed. And so then we have that. I'm also going to divide by pi. And so I'm going to have 3/4, and I'm going to add that pi here on the bottom. So you can just combine this as 3/4 times pi, like this, v, and then I'll have r cubed. So in order to get this r cubed, you can either look at it in its fraction form, where I'm doing 3 times 1/3 in order to get just 1, or you can look at it as it being it's given to the power of 3, so cubed. You can also take the cube root, which should do the same thing as timesing by 1/3. And so then I can do the cube root of 3/4 pi v. And so we can have that as our r. And so r has to be greater than 0 in this case, because anything underneath a square root or any kind of root has to be a positive number, or we go into imaginary. And so in this case, we're wanting any positive value that can be plugged in for r, so we get a positive volume, because volume can't be negative in this case in our interpretation. Okay, moving on to part 30. We're going to be solving the linear inequalities and graphing the solutions and writing the solution in interval notation. So with interval notation, we know that things that it can't equal will be in parentheses, and then we also have things that it will equal to in brackets. So if it's allowed to be in something, it'll get a bracket. And then also for inequalities rules, if we know we divide by a negative, we know that the inequality, so if I have it like this, it now flips to this when I divide by a negative on any side. So let's start with this first one. -6 minus 5x is greater than 24. Let's move our constant over. So we're going to add +6. And we're going to have -5x greater than 24 plus 6, which is 30. And then I'm going to divide by this -5. So what this tells me when I divide by the negative, that means that this sign right here is going to flip as well. So x will be less than what this value is. 30 divided by -5 is -6. Okay, so this is for part A. Let's move on to part B. And so for part B, we're going to have x greater than -5/2 c minus 2. I'm going to add the constant over, and I'm going to get 10 greater than -5/2 over c. And then I'm going to times by the flip of this, so I'm going to times by -2/5 and do that on both sides. And so then I will have negative, and also since I'm dividing technically by a negative, even though it shows I'm multiplying, because I can still divide this as -5/2, I'm going to flip the fraction as well. So I'm going to get a less than here. And so then I'll have -20 over 5. So -4 is less than or equal to c, or c is greater than -4. Okay, so now I need to do interval notation. So this is for any x value less than -6. So I can plug any value. So I know on my left-hand side, I'm going to go to -infinity because it's less than. And so then I'll have a parentheses because it won't equal -infinity, because that's kind of like a bound in this case. But for this -6 side, I am going to want a bracket because I'm allowing it to equal the -6. Now in this case, on this right side here, I'm having c greater than -4. So on my left-hand side, the most it can be is the -4, so it's equal to. If it was greater than just 4, I would have a parentheses 4. And then anything greater than that, so I can go to infinity, and it has no bound on it, so we're going to give that a parentheses. So we can show this in line graph form. So we'll just show where these points are at. So we'll have our 6 here, and then, sorry, our -6 here, and then our -4. And so I can have anything for 6 less than 6, and it's a bracket, and I'm basically going to fill anything less than it here. And then also on the -4, I'm going to give it a bracket, but in the opposite direction, and I'm going to have it anything greater than this. So these are numbers. It could be -4.6. It could go all the way to 10,000. But either way, I will be able to go anywhere greater than that. And here I can go to -10,000 and beyond. So that's just showing graphically what that would look like. Okay, let's look at 31. So with 31, we're going to be doing intersection and union. So the first one is asking when A union B. So A union B is the concept that you're adding both, like anything in one is also with the other when you union these. So A union B would be you're adding all these terms into one thing. So we'll have 0, 2, 3, 4, 6, 8, 9, and 10. So we have 0 from the B, we have 2 from the A, 3 from the B, 4 from the A, 6 from the A and B. So you can't double count them, so you'll just have only 6. And then you have 8 from here, and the 9 from here, and the 10 from here. So basically anything in either of them basically gets added into one large set. Versus the difference in A intersection B is anything that is in both of them. So we saw here when I couldn't double count the 6 because the 6 is in both of them. So that's where they have an intersection. They both have 6 inside of them. So A union B is when you add any set, both of the sets together and adding them all the terms. For A intersection B is a term that's inside of both of them. So that's for number 31. Okay. Number 32. So number 32 is a little bit like 30. However, we're likely to get compound inequalities, which means we're likely to have 2 or more answers. So in this case, we're going to want to solve for x. So let's do that. So we have 3x minus 2 plus 2 is less than x minus 8. So I'm going to distribute out here. So I'm going to have 3x minus 6 plus 2 is less than 8x minus 8. We're going to simplify here and have 3x. And we're going to have minus 4 less than x minus 8. Then I'm going to, let's move the x over on this side over to here. So we're going to have 2x, I'm going to minus the x, minus 4 less than negative 8. Then I'm going to add the 4 here, and I'm going to have 2x less than our negative 4, and then I'm going to divide by 2. And so I'll have x is less than negative 2. But we also have an OR statement, which means that's our second one. So OR is one of the solutions. So then we'll have 4 times x plus 1 plus 2 greater than negative 2x plus 4. So we're going to distribute out here and have 4x plus 4 plus 2 is greater than negative 2x plus 4. Then we're going to have 4x plus 6 is greater than negative 2x plus 4. I'm going to add this 2x over, and we're going to have 6x plus 6 is greater than 4. I'm going to minus this 6 over, and I'm going to get 6x greater than I have negative 2. So dividing that by 6, we can actually simplify this by 2, and we're going to have negative 1, and we're also going to have 3. So we'll have x is greater than 1/3. So with this, we're going to draw a line graph and do the interval notation. So I'm going to draw one big line, and I'm going to have negative 2 here, and I'm going to have negative 1/3. So looking at this inequality, we know that it can equal 2, so that means we get a little bracket. So we'll do a little bracket here. However, it's anything less than that, which means that we have the negative infinity on this side. Negative infinity is not bounded like numbers, so we're going to have a parentheses where it's equaling. We have a bracket. Then we also have an OR, so we have the union between these two. And so we'll have a negative 1/3. And we know it won't equal 1/3 because there is no equal down here on this part. So we're not going to have it equal. So we have no bracket. We'll have a parentheses. And then we'll have that to infinity because it's anything greater than that. So how we can look at this is we can give this a bracket here. And then we'll have a parentheses here. And then we'll draw our lines on what direction they'll be going. So anything less than the negative 2 is happening here, and anything greater than the 1/3 is happening here. Okay, so that is for part A. Okay, let's move on to part B. So on part B, we have an AND statement. So 3x plus 5 is less than 17. And then we also have 5x plus 2 is greater than negative 8. So we're going to solve for 2x values, and this is an AND statement. So we're going to minus 5 minus 2 here. So we'll have 3x is less than 12. And then here we will have 5x is greater than negative 10. Divide by 5. We're going to divide by 3. So x is less than 4, and x is greater than negative 2. So let's draw this out in the number line. And so we'll have a negative 2 here, and we'll also have a 4 here. So if we want to look at interval notation, we're going to have anything, it can't equal 4, so we're going to have a bracket here, so 4, and it can be less than, so I'm going to head towards the negative infinity direction. However, once I'm heading into that direction, I am going to bump into negative 2. So I'm going to have to look at what happens after that. So I'll have the negative 2, and it's asking for anything greater than negative 2. So negative 2 is going to have, it's going to have a bracket, and it's going to have the negative 2 and anything greater than that. So it's going to head towards infinity. However, once it heads towards infinity, it's going to bump into 4. So basically they're bounded by each other. So I'm going to have a comma here, and I'm going to have a bracket here, and I'm going to have anything in between these numbers. So for its notation, I'll have its negative 2. So I'll have the negative 2, and then I'll have a comma to the 4 with a parentheses. So basically showing the in between the values. So that's the and it also shows us the difference between part A when it had the or. So the and basically shows us that we're going to be bounded between two numbers. There we go. Okay, let's move on to number 33. So we have a double inequality, which just means whatever we do to one side we'll also do to the other. So we're just combining the inequality, I guess, in a way. And we're just going to solve for x, and we're going to do what we do to one side to the other. So we're going to times 3 on both sides. And so we're going to get -6 is less than or equal to -2x plus 1, which is less than 12. And then we're also going to do -1 here. And so we'll have -7 less than -2x plus 1 less than 11. And then, sorry, I'm going to get rid of that because we added that already. We're going to divide by -2. And then remember, when we divide by a negative, we also need to flip our inequality. So we'll have to have this greater than here. And we'll have to flip this one as well and do it greater than 11, negative. And so when we do that, we also can like separate these. So with this being flipped where it's the 7/2 is greater than -x, it's also the same thing as x is less than 7/2. And then we can just keep this in its form here as x is greater than -1/2. So let's draw out a number line. So we have 7/2 here. We have a -11/2 here. Okay, so now that we have our number line, we're going to basically look at, we want anything less than the 7/2, but we also want it greater than the 11/2. So we're basically bounded by each other. So since they both have an equal to sign, they're both going to get big brackets. And then we know that it's anything in between them. So if we're writing that in interval notation, we can keep those brackets. So we'll have the -11/2, and then we'll also have comma, the 7/2 in brackets as well. And so now we have our solution graph form, and we also have it in interval notation. Okay, on number 34, we're basically going to be making our own inequality. So we're seeing that we're dealing with an average. So an average is the sum of all of our values. So we'll do I to 1 to n. So in this case, we're going to 4 months, and we're starting out with the first months, and then we're going to divide by how many of them there are, or n. So n is to 4. And then we're going to have that greater than the average value. So in this case, we're given 4 months. So let's look at those 4 months. So on those 4 months, we have to where we have the first month, which is the 8.54. That's how many inches. So well, I guess you can look at this instead of x, you can do it as y of I, but either way, it has the same premise. So then we have 5.72 for the second month. Then we also have 8.63 for the third month. And then we're looking for this fourth month that we don't know about. So we're going to label that as X, which is our fourth month, as in September. We're going to divide this by how many months we're averaging by, and then we're going to make this greater than the average number. So now we have an inequality that we can solve. So the first thing we want to do is times 4 on the 7.83. So that equals 31.32. And then we're going to have this greater than the 8.34 plus the 5.79 plus the 8.63 plus x. In order to get x by itself, we need to minus all of this onto the other side. So we'll have x is greater than 31.2 minus 8.54 minus 5.79 minus 8.63. So let's see what that number is. 31 minus 2 minus 8.54 minus 5.79 minus 8.63, and we get that x is greater than or equal to 8.36. So in order for it to exceed this number of 7.83, it has to rain 8.36 inches of rain or more to exceed the monthly average in September. Okay, and so that's what we have for number 34. Okay, let's do number 35. So with number 35, we're going to start solving this like a regular equation that we see, and then we'll get to a part where we get a little stuck. So we're going to add the 4. We have 16, and we have the 2 of the 3x plus 5. Is that equal? We're going to divide by the 2. So now we're here with this absolute value, and we have 8. So what we want to do in this case is, in order to get rid of the absolute value, we want to add a plus or minus onto this 8 side, because we know any value that's going into here for x can be a positive value of that or a negative value of that, because the negative basically goes away once the absolute value comes into encounter. So we're going to solve it now with the plus or minus to account for that. So minus the 5, so we have 3x equals negative 5 plus or minus the 8. We're going to divide by 3. So then we're going to solve for x with its plus value, so minus 5x plus 8 over 3. We're also going to have x equals minus 5 minus the 8 over 3. So then we'll have x equals positive 3 over 3, and we'll get 1. And we'll also have x equals negative 13 over 3 for part A. Now let's move on to part B. Okay, for part B, we'll have x plus 4, and I'm actually going to move the other one onto the other side. So what I'm showing you with this is that with this, we're going to have positive and negative values come out of these absolute values. So I'm going to set a negative to a positive one, and then a positive to a negative as well. So I'll have negative x minus 4 equal to the positive of this one. And then I'm also going to set this as my positive x plus my 4 equal to the negative of this one. So then I'm going to solve these. So I'm going to add the x here, and I have negative 4 equals 2x minus 7. I'm going to add the 7, and I'm going to get 3 equals 2x. Then I'm going to divide by 2. So then we also have this one. I'm going to add the x. I'm going to get 2x plus 4 equals 7. I'm going to minus the 4. And then we're going to have 2x equals 3. And we're going to here. So we see that x equals 2/3. So no matter how you do this, you set one to the negative positive or the positive to the negative, you will always get there's only one value in this absolute value to where you're going to get an answer. So there's only one solution with an absolute value problem like this. Okay? Let's move on to number 36. So we're going to write out this first one, and we're going to have plus 2 and less than 14. So we're going to solve this like a regular inequality to start off. So we're going to do that. We'll get 12, and we'll have 3 minus 5 minus x. Then we're going to divide by that 3. Remember, if you divide by a negative, it flips. So with inequalities, usually I did with the equal, I gave you a plus or minus. But with inequalities, we're actually going to solve this to where we're going to make everything inside of here a negative, and then also have a positive. So we'll have a negative 5 plus x that is less than the 4. And I'm also going to give you where you have a 5 minus x is just equal to that 4. So we're going to solve both of these like that. So then I'm going to add the 5 on this one. I'm going to minus the 5 on this one. So I'll have negative x less than negative 1. And I'll have x less than 9. So with this one, I'll divide the negative. And remember, when I divide by negative, everything flips. So I'll get a positive 1. So let's draw out our number line. I'll have a 1 and I'll have a 9. So remember that they're both equal. So that means you get brackets. So then we have to think about this. For 1, it's everything greater than it. But we also have a parameter with the 9. It has to be less than 9. So it has to be anything in between these numbers. So where it's like that. So that's what we have for there. Then we can also show that in interval notation with the 1 and the 9. And for me, I show the visual first because it kind of helps to see what it looks like. But you can also start with just your interval notation of knowing in between and thinking that visually out. Okay, let's move on to part B. Okay, let us move on to part B. So we have 4 absolute value x plus 2 minus 10 greater than -6. So I'm going to add the 10, and then I will get 4 greater than 4 absolute x plus 2. I'm going to divide by the 4, and I'm going to get an x plus 2 inside of here greater than 1. So then I'm going to do a negative x plus 2 greater than this one. Oops. One thing that we also have to remember is when I distribute out a negative, you have to give the negative also to that too. So I made that mistake there, so make sure that you don't make that mistake. X plus 2 greater than 1. So we're going to add the 2 on this one. I'm going to minus the 2 on this one. So I have negative x is greater than 3, and I'll have x is greater than -1. So with this one, I need to divide by the -1. Remember, when you divide by a negative, everything of the inequality flips, so minus greater than -3. So let's draw out a number line. So then I'll have a -3 and a -1. And so they're both equal, so go ahead and draw those brackets. But when I'm drawing those brackets, I need to think about which direction each one is going. For the -3, the bracket is going to go this way because I'm going towards anything less than that -3. And then on our -1, I'm going anything greater, so I'm going the other direction. So I'll go towards this way. So then we have 2 of those to where our number line is we have the -3 left and the -1 right. You can also draw this in interval notation. So then I will have to have a union because I have this. So I'll have a negative infinity because they're not bounded the same. I'll have the -3 and then I'll have a bracket, and I'm going to union that with the -1 comma to infinity. So now I have that where I have an and statement where I have it going from its values of the -3 less and then the greater than the -1. Okay, let's move on to number 37. So we're going to look at special case solution sets. So let's first start solving with this first one. So if I have less than -3, so let's say I do the negative of the +5 less than -3, and then I also have our positive of that minus the -3, so I can do +5. I can get x less than 2, and then we can also do this one, and then we can have -x, where we have minus -8 divided by the negative. I'm going to flip everything and do it like that. So you think, oh, we're finished with the solution. We are in fact not, because if I put in 8 into here, I have less than 3. 3 is not less than -3. And then I also have -2 minus 5 is less than -3. Then I have -7 is less than -3. So -7 is not less than -3, and 3 is not less than -3. So in this case, we have a no solution to this answer. You can even tell a little bit by the idea of inside of here when I'm plugging in values. You can have things, we know no matter what, with this constant being here, we will ever have anything less than -3 when plugging in something. Okay, so let's move on to part B. So on part B, I have x less than 2 is greater than -4. And so I can do x minus 2 is greater than -4. And then I also have x minus 2, plus that is greater than -4. So let's solve. Okay, so I'm doing this quickly because I'm going to show you something here at the end to where it doesn't matter what I put in here. So if I have 6 and 2, it has to be greater than 2. It also can be less than 6. So but it's not saying that I can't plug anything less than, like if anything behind here is also less than 6. So like -2 is involved in that. But I'm also doing anything greater than -2, but it's saying that it doesn't mean I can't stop past 6 also in this case. So if I think about the inside here, if I'm putting in a number, let's say I plug in R4 minus 2 and -4, I have to remember that I'm going to get a -6 in here. So no matter what value I put in here, no matter how negative, it's always going to be greater than 0 because it's absolute value. I'm getting a positive number. So no matter what I put into part B, I'm going to get any number that can go into that solution. So I can just do from -infinity to infinity, or all real numbers, because all numbers can fit within this interval. And now we're going to move on to part C. Okay, on part C, we have x plus 1 is less than or equal to 0. So the one thing that's false with this statement is that it can never be less than 0, because anything inside an absolute value number has to be greater than 0. So the only account that we can apply for is x plus 1 when it's equal to 0. And so in this case, we're only going to have one solution where x equals -1. So that is our only solution for this one, because our solution has to be greater than 0. Okay, moving on to part D, where we have x plus 1 is greater than 0. So it fits the idea of what can be greater than 0 for the absolute value bar. So, but the thing for this one is, let's do -x minus 1. So we'll do the negative and the positive. X plus 1 is greater than 0. So we can add 1 here, and then we'll have where we have -x is greater than 1. And we also have -1 here. And we'll have x is greater than -1. We'll divide this negative, and we'll have x is less than a -1. So now we have -1. So let's draw this. So we know it can't be equal to -1. So there's kind of a space here where nothing here at -1, nothing is going to happen here. Okay? So with that, we have anything that is greater than -1. And we have anything that's less than. So there's a space missing here where the -1 can exist. So we can do anything that is from -infinity to -1, but we can also union that where we have -1 to infinity. So the only space where it doesn't exist is here at -1. Okay, let's look at problem number 38. A box of cereal is labeled to contain 16 ounces. A consumer takes a sample of 50 boxes and measures the contents of each box. The individual content of each box differs slightly from 16, but no more than 0.5 ounces. So when we're looking at this, we're basically saying the baseline is 16. However, we can be greater than 16 by 0.5, and we can also be less than 16 by 0.5. So in order to draw an inequality, we'll have 2 of those. So no matter what, it has to be less than or equal to 0.5 ounces that it can differ by. But we're basically saying from that 16, we can do 16 minus that x. So this could be for anything in between that value on this side, where it's going to be less than that, versus we have this one where we have x less than 16, or sorry, x minus 16, where it could be anything greater than that 16 has to be less than the 0.5 content. So that's what we can do for part A when we set up an inequality to estimate that x. Then we need to solve that inequality. So then we have 16 minus x less than 0.5. So then we can do a -16 plus x less than 0.5. And we can also do a 16 minus x less than 0.5. So when we do that, we can do a plus 16. And then we have x less than 16.5. Then we also can do this one where we have minus 16, which is a -15.5, x less than that. and then we can do divide by the negative, so that flips it, so it has to be greater than 15.5. Now we could do this one, however this one will give us the same result as this one. So when we do that, now we have an inequality where it has to be greater than 15.5 but less than 16.5, which is that variance of the 0.5. So for part B, we can say the contents of the boxes of cereal have to vary between 15.5 ounces and also 16.5 ounces between there. So if you think about it, you can add the 0.5 or you can minus the 0.5. So that gives you an easier way of doing part B. So it's a fact check of like, did I add 0.5, did I minus 0.5? But we also have it where it's in its inequality form, but also the contents of when we're thinking about reality. Okay, that's all for part 3 of the college algebra exam review. Here is all the answers for the parts that we did in this one. And then I also want to wish you guys a good luck on your exam. I know you're going to do great. Goodbye.